Okay guys, so I'm gonna do one more video today, and this time I'm gonna reach back to section 5.3, in which we were solving trigonometric equations. And in some cases we just wanted one solution or a couple of solutions or all the solutions that were in the interval from 0 to 2 pi sometimes. But sometimes we wanted all the solutions. In other words, we wanted an expression that covers everything that would solve the equation. So we're going to take this equation here and we're going to talk about both cases. What if you just want a couple of solutions? What if you want all the solutions? So, all right, so here we go. So let's say you just want a couple of solutions. So, I mean, we'd start either way. We'd start the same way. We'd start isolating the expression, right? And at this point, because we have this square, right, we want to take a square root of both sides. Now, when you take the square root of both sides of an equation, you need to use this plus or minus symbol. Remember, it's because a negative squared is also a positive. So if sine of 4x equals the negative square root of this, when we square it, we're still going to get positive 3/4. All right, now also, since we're taking a square root of a fraction here, that means we can just do the square root of the top and the square root of the bottom. And of course, the square root of 4 is 2. So you see, this is actually a fairly familiar thing. Square root of 3/2. We should recognize that from the unit circle. So what we have now is that the sine of 4x equals, and I can even make two equations out of this. The sine of 4x equals positive root 3/2, and the sine of 4x equals negative root 3/2. So now we want to look to the unit circle, so we better bring that in. We're going to look to the unit circle, and think about, where do we see sine of root 3/2? That's going to be close to the top, right? Root 3/2 is up here, and we have this angle, we have this angle, in other words, that angle and that angle, and those are the ones, all right, that have that sign. So this is going to be pi over 3, and this is going to be 2 pi over 3. So what that means, guys, that doesn't mean that those are solutions. X does not equal pi over 3. What that means is 4x, right? Because this is the argument. Sine of 4x equals this. Well, then 4x itself is going to equal pi over 3 or 2 pi over 3. And we can also say, because we could go down here to negative root 3/2, these angles, right? And this is 4/3 pi, this is 5/3 pi. Because of that, we could say that those are also potential values for 4x. So 4x can equal 4/3 pi or 5/3 pi. So now, if we actually wanted to solve for x, which we do, we would divide by 4. So if we divide everything by 4, remember, dividing by 4 is the same as multiplying by 1/4. So here I'm multiplying by 1/4 because that is the same as dividing by 4. And look what I get. Pi over 12, and I get 2 pi over 12, which is the same as pi over 6. These are actual solutions to the equation. You can try them out. You can put them right back in. Try it. Multiply by 4, take the sign, square it, multiply by 4, subtract 3, you'll get 0. I know that's a lot of work, but you know, you can be sure of yourself that way. Okay, so again, I'm going to divide by 4 here by multiplying by 1/4, and I'll get, if I multiply by 1/4 here, I'd have 4 pi over 12, which is just pi over 3. So that was a solution after all. And here I would get 5 pi over 12. Okay, so these These, my friends, are solutions, basic solutions to the equation. Now, that's actually, okay, so what do we want to do now? Those are just examples. If I just asked you the question, you know, if I just basically said, give me some solutions, then of course you would have some, that'd be the end. If I want to know what are all the solutions, right? Now we have to think, what do we want to add on? So take each one of these. That's all just in quadrant 1. Okay, well, you notice that these solutions here are all in quadrant 1, okay? So you've got this one, pi over 12. You've got pi over 6. You've got this one, pi over 3. And then you've got 5 pi over 12, which is right here. Okay, now think about what we're dealing with here. We've got sine squared of 4x. In other words, our b value is 4. So the period of this thing, period, is equal to 2 pi divided by b, which in this case means the period is just pi over 2, which is just from here to here, right? So from going from here to here, we've picked up 4 solutions, but we've only done 1 period. So what do you suppose is going to happen when we continue on to pi? We're going to get 4 more, right? We're going to get 1 there, well, not here. We'll get 1 here, 1 here, 1 here, and 1 here. And then when we continue from pi to 3 pi over 2, we're going to get 4 more. Well, you get the idea. We'll get 4 each time. In other words, whatever we have here, we're going to get again here, we're going to get 4 more here, and we're going to get 4 more here. So here's what we could do. We could take our 4 solutions here and add the period being this, right? We got that by taking 2 pi and dividing by b, which is 4. So our solution set goes like this. X equals pi over 12 plus pi over 2 times n. It equals pi over 6 plus pi over 2 times n. Pi over 3, don't be lazy, write it all out. And finally, that's not too much work for you, right? Okay, and finally we remind the reader that by n, of course, we mean all integers. This means n belongs to the set of all integers. This is our general solution. So this right here would be fine if you just wanted a couple of solutions, but this gives you everything. Usually, our period that we add is 2 pi, right? That's just as a final note. This, you notice, is usually 2 pi. Here it's not, and it's because of that right there.